Hello, welcome to Topper Machine. I'm Josh Topper. Today's job is to build the replacement end, the pivot end, on the boom of an excavator. My customer has changed over to a different bucket and different attachment style, so he's actually cutting the end off of his boom and putting a new pivot style on there. So we're taking this material that he brought and we're building the whole component. Now this is a big job, so let's get started. Okay, so now that I've made it this far, now is the fun part where we gotta try to get it all indicated in. And first thing I need to do is get a little support on the tail end. And the way I do this is I made this plate with a center in it years ago. And I just push that up, butt it up to it. And that helps me hold it up in there. You know, just puts a little light tension on it. In fact, I'm going to run it out a little ways. So locking my tailstock down. And that just helps hold a little tension on it so I've got some, it's not going to want to fall out. It's just holding it to keep it from falling out. So 4 minutes, and because this is so rough, I mean, it's hard to indicate, but we're pretty close. And what I'm gonna do is clean it up, take a skim cut off of it, face it, center drill it, and then we'll switch back over to the 3-jaw and use the steady rest. But this will get us started. So because the material is so rough, and we gotta get it faced off to get a center in it, I'm going to run it nice and slow to start with. 180 RPM, and we're just going to take a little at a time, just whittle away at it. You know what? That is making me nervous. I'm going to go ahead and just center drill it, and I'm going to face up as close to the center. I'll use my live center as close as I can, and then I'll take my face cut. And then when we put it in the 3-jaw, we'll turn it around, use our steady rest, face it, and we'll just drill from that end, the far end, up by the chuck. And I'm just using a little center because I don't need a big hole, and that'll just keep me a little further away from the cutter when I'm trying to face this end. That feels a lot safer. Let's go ahead and face this end off as close to the center as I can get. And I still don't want to feed super fast just because I don't want to cause any extra strain on the machine. And we're getting close to the center there. I just got to watch to see where make sure I don't hit my cutter on the center. And we're getting close. That's probably close enough. I'm going to take one more pass on this just to make sure I'm 100% cleaned up. He had it cut right to size, which I wouldn't have done just because there ain't much for cleanup that you can do, but We got 100% cleanup there. I sped my RPM up to 250, and I just took a cleanup cut here just to see where I'm at. And I'm right where I want to be. I'm a couple thou over 7-inch, which is fine. So what I'll actually do is I'll just take a couple more there, and we'll turn the coolant on because this is going to get dirty. We'll run a little coolant on it just to keep it clean, keep the dust down. And running 250 RPM. So let me just put it right on the cutter. Maybe it won't spray so bad. Okay, so I got it up in our steady rest, well, up in the chuck. The steady rest still isn't connected. It's just floating there. And what we're gonna do again is take our puck, our centering puck, and use that to push it tight into the chuck, into the jaws. And that should work pretty good there. We'll go ahead and tighten the chuck up, just spin it a few times to make sure we're good. Looks pretty good. We'll throw an indicator on there too before we're done. And might have to do a little indicating, but looks pretty good. All right, just a quick spin to see where we're at here. And we're a little off. About 8 thousandths. So I'll go ahead and I'll tap that in with the mallet and get it as true as I can, then we'll set up the steady rest. All right, well, the only way I'm going to get any closer is to actually run it and set up our steady. So I'm just going to bring my rollers in close. One at a time, and then final adjust them with it running. First thing I'm going to do is turn that outside diameter down to size. And I'm going to bring it in close, and then I'll do a finish pass just so they line up pretty good. All right, now we're at the point of needing to bore this thing out and open it up. And what I've got here is one of my favorite tools to use on the lathe or the radial drill is a spade drill. And this comes from one of my viewers. He reached out to me. He had a bunch of them that were too big for him. So he asked if I was interested, and I said, sure, I'll buy what you got off of you. And this is one of them. Got a 2 7/16 insert in it. So let's get this in the lathe and try it out. And if anybody's interested, he does have a bunch of smaller sizes, and I'll put his phone number in the description below. You can text him, and if he's got any left, he'll reach out to you and let you know. And as soon as they're gone, I'll pull his phone number down. All right, let's get to drilling. Well, I'm as far as the spade drill will reach. I got 10.5 inches. I'll go ahead and spin it around and then bore in from the other end with the spade drill. It shouldn't be long now. We should be poking through. And there we go. Yeah, I should have probably slowed it down when we punched through, but we got through. Straight shot all the way through. Yeah, it finally decided to start raining. We've been pretty dry here for quite a while. So that's a good thing. So I got the big boy boring bar out here. We're gonna see if we can't open this up to, we're gonna go just over 4 inches. So about 4 1/4, I think, because the pin is 4 inch. I'm taking a pretty heavy cut here. I'm taking a 1/4 inch, 1/8 inch aside on the bore, and I'm feeding at a pretty good rate. C1, about 14 thou revolution, and I'm running 180 RPM, so it's cutting pretty good. I'm just pushing a little coolant in there just to keep everything lubricated. I've got a little vibration, but not horrible. Like I said, we're just going to rough this bore out and then we move on to the finished bore. Now the nice thing about jobs like this is I can set the lathe up and walk away. While this is boring, I just set a stop, it cuts out the feed, and then I just come over and restart the cut. Because this is going to take a while, I can be doing another job. Okay, so we're mostly opened up to what we need. I'm going to actually need to go another little bit. I got clearance in there for grease, but I want to go a little bit more so that it can knock out the bushings when they're done. So I'll just take a nice light little cut just to see if I can smooth it out. Okay, so taking a light cut isn't working well with this bar. There's too much chatter, it's too far out, too loose. So I'm gonna go ahead and just take a deeper cut and it'll be okay. I've got plenty of clearance in there, but just to get it smoothed up and a little bit more than what we originally had. Well, now that I've started the chatter, I can't get it out. Even going deeper, it doesn't want to stop. So I think what I'll do, I'm fine as far as my depth, totally fine as far as the inner bore. So I'll just shorten up my boring bar now, and we'll cut the bushing surface next, and that should eliminate our chatter by getting the bar in further. There, so the customer wants about a 4.5 inch bushing, 4 to 4.5. So I'm going to set my bar here pretty short so that we don't get too much chatter, and I'm going to set it at 5 1/4 just to give me some wiggle room here so I don't hit anything, and I'll get my height set, my angle set just right. Now by being shorter, we should be able to speed it up as well. That looks like it's cutting pretty nice. I think I'll get the coolant going on it again. And I'm only using the caliper just until we get close, and then I'll get out the inside micrometers, but 4,350. And the material he gave me was 4.5 outside diameter, and in order to take some off of that and clean it up, I really need to go down to 4 7/16, but that leaves an awful thin wall with a 4-inch shaft. I don't really like that idea. But it's the material the customer brought me, and it's what he wants, so it's what I'm gonna have to use. I think I'm gonna shoot for just under 4.5 and clean it up. Maybe I'll shoot for 4.75, and that might be pretty safe. I should be able to clean that material up. Put the coolant back on it. Yeah, she's starting to warm up a little bit. I might want to run the coolant on it just to cool it off. But we'll see where we're at here, and right around 4:30. So I'm going to take another 40 thou. We'll just let it run for a while and cool. All right, it's been a couple minutes, and that's already way cooler. Now we can go back to doing our bore. Okay, so I got my Starrett 823B inside micrometer here, and let's just see where we're at. And of course, I already did calibrate this with, I used a gauge block to check my caliper, and then I checked this with the micrometer. So 474. Boy, as nice as that finish is, I wonder if I should even bother going that extra 5. You know, since I'm the one making these and making the bushings, I'm going to leave this end be, and I'll just make the other end to match 474. And every time I do something like this, I make notes of it in their file, the customer file, and on the invoice. So the invoice always says the bushing size when I have to make a custom bushing. So we'll just chamfer this one, and I'll flip her around, and we'll do the other end. So as you can see on this end, we stopped short of coming through, and it's mostly because I didn't want to hit my jaws. So what we'll do, we'll start here, and we'll just bore that out until we get down to the inside surface, and then we'll bore our step in for our bushing. That's 200 thou gonna pass, 100 thou side. That's a 1/4 inch. I decided to push it a little harder. It seems to be cutting just fine. Sitting cool. You can see the coolant coming out both ends, and that'll cool the whole part off pretty good. So I'll get this thing cooled down a bit, and then we'll finish her off. All right, she's cooled off good. Just take a quick peek, see where we're at. 350. About 60 thousandths. Right there, and we'll let her cut. All right, we'll see where we're at here. And that's the thing with these inside mics, you got to feel around a little bit. $405. So I got a little ways to go. Another 69 thousandths. So I think I'm going to try doing this in one pass. Means means I need to go to 16. And you just take a little cut like that to enough to get it where you can get your micrometer in there. Three thou more. And right there. Now we should have it. So I'm going to just take a little deeper and measure it again. $474, right on. Now the only problem with doing it this way is then that first little bit's going to be loose, but you only got a little bit that's loose. Your bushing will go in there nice and will fit just fine. So now that all the turning's done on this, the bore, everything's nice, we'll get it up on the boring mill and drill our grease hole. Well, we're all set up. We're gonna center drill and then drill for our tap size, which is, we're gonna drill for a 1/8 inch pipe tap for the Zerk. So it's 11/32 drill, and then we're gonna counter bore it with this 1 inch end mill, so that if you watch the video of the grease coupler, you need a larger recess. So we'll do the 1 inch, and that'll give them room to clean it out also. So let's get started. All right, let's go ahead and bore this in a little bit. I hope you're enjoying the close-ups. Well, there it is, all done. Next week's video, we'll do the bushings with the material the customer brought me and finish the pin, and then this can get back into service. So, until next time, get out in your shop and get it done right the first time.